I'm standing on this disused railway line that I walk my dogs on. We used to take salt from the salt processing works up that way, about 4 miles that way, in Middlewich and Northwich, in this direction, although I'm not absolutely sure where it used to take them to. Maybe to Liverpool, perhaps? Shipping, I don't know, something like that. Or maybe to Stoke-on-Trent, actually, the potteries, that's what it'll be. But anyway, it's an old disused railway line which has been converted into a public footpath. It's just great for walking the dogs on. And it has this great perspective to it. And what it's reminding me of is those optical illusion puzzles that you sometimes get, where you get two lines which sort of look a bit like this. I'm trying to draw it on the ground with my foot here, which probably not going to work. You have two lines which appear to be like that, appear to be converging. And then, but just lines on a page, no detail. And then you have two horizontal lines of equivalent length, of the same length. I'll point this thing on the ground. I don't think it'll work, but we'll give it a go. The day's creation is. And what the optical illusion points out is that the line at the top of the image, the one that, well, which is the same length as the one towards the bottom, the one at the top appears to look longer. The line that's nearer the point where the two vertical lines converge appears to be longer than the line towards the bottom of the page where they're more divergent. And the usual explanation for that is that part of our of the non-conscious processing of our cognition recognizes those two converging vertical lines as perspectival. We recognize that there's a perspective in operation when we see that, and with perspective comes distance. So if there are two lines, two horizontal lines, which appear to be the same length, the one near the point of convergence must be longer because it must be further in the distance. And hence, if it's further in the distance and it appears to be the same length as the one closer up, in actuality it would be longer. So, it's a very seductive effect, even though it's a very minimally drawn perspectival effect. It's just lines on a page. The effect is very, very convincing, to the point where it's almost impossible not to see the top line as being longer than the bottom line. It's not something you can consciously think your way around, really. You can't apply, you can put a rule on it and measure it and sort of know intellectually that they're the same length. But you can't apply that knowledge to your perception. Your perception keeps telling you that the top line is longer than the bottom line. What that reminds me of, in a slightly different way, is what I've spoken about before, which is to do with what Michael Polanyi talks about in his essay Structure of Consciousness, when he talks about three-dimensional vision. How we look around the world now, our sense of depth, our depth perception, is a product of the slightly different pictures that our right eye and our left eye are seeing. Because our right and left eye are separated by about 3 inches, we're getting tiny little differences in the images that are being produced. And it's those differences which give us this illusion. Depth, if illusion is the right word. It's an apparent depth perception. And again, like the optical illusion I just spoke about, it's not something we can retrieve and perceive directly. We can know that intellectually and consciously that when we see depth, what we're actually seeing is slightly different images. We can intellectualize about that and sort of know it completely academically and correctly. But that doesn't provide us with any more ability to see those images separately. In fact, if we take two stereogram images, the ones that you put in the little viewers to get artificial 3D effect, if you get two stereogram images and look at them side by side, it's very difficult to see the difference. You can't look at one to the other and say, oh, I can see slightly more the north face of that tree than I can of the north face of the other one. It's almost impossible to tell the difference consciously. You have to just sort of rely on your cognition, your non-conscious cognitive processes do that, and they do it completely seamlessly and completely opaquely. You can't go back. See how it's done. And I think that must be terribly significant, that in terms of our ability to conceptualize space and our all of the metaphors that we use to talk about space, because our understanding of space is so convincingly and opaquely constructed in this highly phenomenological way, in which we are the centre of our little world, and the spectrum lines running out in all directions around us, and objects diminishing with distance, and parallel lines which are the same length appear to be different lengths. All those effects which are produced by that presumably are going on even when we're not thinking about it. So when we're using covert metaphors of space, it seems to me extraordinarily likely that our understanding of space is that kind of understanding. It takes a great effort of conscious will to understand space in any other way, really. We have to be pretty academically sus to understand Cartesian space. It took Descartes to think of it. And Newtonian space, it took Newton to think of it. It took geniuses to think of these things, standing on the shoulders of giants. So, even consciously it's hard to think of those things. Our non-conscious world is not going to be sure. So it seems to me that for those reasons, when we're talking about space, phenomenal space, the space of non-conscious processes, the space that are being drawn on, that we're drawing on unthinkingly to construct metaphors in space, they're most likely to be that phenomenal space, the space of optical illusions, the space of things diminishing with distance, the space of convergence, and not the space of Newton and Descartes. All that retreats into the distance must converge.